Morning everyone. You would have seen that we're going to be using this forum to continue our lessons for the foreseeable future. So I've outlined my expectations in the forum and I thought I'd take you through an example of one of the things we're learning about today, which is Hess cycles. So Hess was a physicist who realised that we could use the first law of thermodynamics to help work out the enthalpy change for a reaction. So the first law says that energy cannot be created or destroyed. That means that whatever route I take to go from these products, so these reactants to these products, the enthalpy change will be the same. So I've chosen here an example of a reaction we did actually a few months ago. For your assignment 1.5, we burnt some alcohols, put the flame under a beaker of water, watched what happened to the enthalpy, and watched what happened to the water temperature. So one of the things we'll do this week is repeat that practical and use it as part of the pass for Unit 16. You don't need to repeat it though, we've already done it, so I'll be sending you some data to use with it as well, okay? So that means that one of the methods of determining the enthalpy change for this reaction is to do that practical. The other method, well actually there's two other methods, one of which is to use our Hess cycles. So to do a Hess cycle, we make sure we've got a balanced equation and we imagine that we know what elements made up these compounds and these compounds. I had some carbon, I had some oxygen, and I had some hydrogen. And let's say I know some of the enthalpy changes involved here. I know the enthalpy change of going from the elements, which should technically be balanced, up to here. And I know the enthalpy change for going from these elements to those. Okay, so I know how to get to both those sides. The enthalpy change of this is minus 277 kilojoules per mole. The enthalpy change of this, well, it comes in these two bits, these two compounds here. And we've got, for the CO2, we've got 2 times minus 394. And we've got 3 times minus 286. Now, I can use Hess's law and this information to work out this enthalpy change. Hess's law states that the enthalpy change for this route must be the same as